This is a video for Math 105, and it's for section 2.1/2.2 about aspects of graphs of a function. And I'm going to work through the group problem. I will post the group worksheet in the other materials section, so you can check it out before you see me work through it here. Okay, so the idea is I have this long list of properties for a function, and I want to, for the graph of a function, and I want to draw the graph of a function that has all these properties. Okay, so all the kind of things that are in this section: domain and range, x and y intercepts, increasing and decreasing intervals, constant intervals, and also relative min, relative max. So let's kind of go through kind of category by category. Domain and range represent the possible x values that you are valid, and the y values that you actually get as an output. So inputs and outputs, or x values, y values. So this means the domain, anything from -5, including -5, or greater. So another way to write this is interval notation. Another way to write this is to say that -5 is less than or equal to x. Right? So the set of all x's such that -5 is less than or equal to x. So here's -5. So basically anything to the right, including -5 and to the right of -5, is a valid input. And then the range is from -infinity to 3, which basically says on the y side, including 3 and anything smaller than 3, I get somewhere as an output. Okay, so you could use think about it kind of as a you could do shading or something to kind of represent that. I'm just going to keep that in mind. Okay, the x-intercepts are at x equals -1 and at x equals 4. So again, that means that it crosses the x-axis there. So that means f of -1 equals 0 and f of 4 equals 0. So whatever it is, it's got to be right here at -1, 0, and at 4, 0. So I've got 2 points that I know that are on my graph. And the y-intercept is 2. That means f of 0 equals 2. So that means it crosses here at 2. So I've got 3 points on my graph. -1, 0, 0, 2, and 4, 0. It's increasing from x equals -5 up to 2. So this part here kind of goes through those points, and it has to increase. It has to equal something at -5 because it's the equal thing. And then up to x equals 2, wherever it is at 2. And then it's decreasing from 2 down to wherever it is with x is 6. So it's going to kind of go up like this, and then at some point it turns around and starts going down until it gets to the value at 6. Then it's going to be constant from 6 to 10. So it's going to be a flat line from 6 to 10. It has no relative minimum, so at some point there's going to be an arrow pointing down. And it does have a relative maximum, x equals 2. So notice that whatever I pick for 2, that's going to be the max. Well, if I look at the range goes up to 3. So what if we make it so that at 2, it's 3? So this, I'm choosing. So there's more than one correct answer here, but I'm choosing that because basically my function is going to go up to that and then turn around. So that's going to be my max. And I also know that's the max of the whole function because of the range. So I need a value here where x is -5. And I need to pick something negative so that it can go up. So I don't know, let's just pick -5, 3. Again, I'm just picking that, And now if I just make a nice smooth curve that goes up, it'll be increasing. And then it's going to have a max here, minus 2, 3. So notice this sets up my domain, sort of the -5 part of the domain. It makes this whole piece increasing. It gives it this x-intercept, this y-intercept, and if I turn around, it'll have a max there. Now I want it to go decreasing until x is 6. So what should I put for x is 6? Let's just make it 2. Why not? I mean minus 2. So now here I got to sort of smoothly go down. So it goes through, it goes down, and then it goes to x equals 6, and then between 6 and 10 it's flat. And that's because of its constant here. And now it has no relative minimum, and it's decreasing after 10. So I have to make it go down and, continue down, put an arrow. So I claim this works. This fits all of these characteristics. So let's go through and check them one by one. Domain from -5 to infinity. So notice anything smaller than -5 is not a valid input. There's no graph here. But from -5 out to infinity, I can pick any x I want and I'll get an output because of this arrow. Range is from -infinity to 3. Again, this arrow goes down. So from -infinity, and the highest my graph gets is 3. So that works. Oh, sorry, check. X-intercepts at -1 and 4. Y-intercept at 2. It's increasing from -5 to 2. So from -5 to 2, it goes up. Notice increasing, decreasing, and constant are always open intervals, right? So this is always less than, not less than, or equal to. So that's very important that it's always open. There's no relative, it's decreasing from x equals 2 to 6, that part goes down, and then after x equals 10, it goes down. So in these two chunks, so 2 less than x less than 6, or 10 less than x. And then it's constant between 6 and -6. In fact, it's constantly -2. It's always -2 from that point, from 6 to 10. It is also -2 at 6 and at 10, but again, when you have increasing, decreasing, constant intervals, they're always open intervals, round brackets. No relative min. You might think, oh, well, here it's kind of a min, but no, it's got to be a relative min. It's so look here. You might think that f of 6 is a relative min because anything to the left of it is bigger, but to the right of it, it's equal to, not bigger. So it's not a relative min. To be a relative min or a relative max, it's got to be either the low or high point from both directions. Same thing here. This looks like, oh, this is a minimum, but it's only got values from one side. It's got to be a relative min from both sides. So notice it does have a relative max, because at this point here from both sides, it's the highest point. So that's true. So everything's true. Okay, so this isn't not the only example. This is just one graph that would satisfy all of those properties.